Adil? Adil,
Yes,
are you there?
my Wi-Fi is lagging.
Okay, no issues here. I'm asking that, suppose that if I compare, not compare, if we basically compare to ourselves, so like I am a boy, you are also a boy. So I'm asking that, am I equal to you or am I similar to you?
Similar.
Similar, na? Because you and I are boys because we shared a common structure of body. Yes or no?
Yes.
We have short hairs, we have mustache, and we have beard, and we have different things as well. So we can say that we are similar, but we are not equal because you have different bodies, and you can say you may be in different in height, you may be longer, you may be short, you may have you can say a chubby one, or like there can be different things, right? Because you have different face structure, you have different haircut, everything is different. But what we basically have, we are boy, and we are boys, which means that we have a common body structure. Yes or no, Adil?
Yes.
Yeah. So in the triangles chapter, basically, we will be doing the similarity, because in the ninth class you have done the congruency, but in the 10th class we basically have to identify whether the triangles are similar or not. Okay. So now,
Okay.
Adil, tell me, these are two triangles. So will you say that these are, you can say, similar or equal?
It's similar.
Right now? Okay, so just a second, let me erase this thing and let me make. Now, Adil, tell me, are they equal or similar?
Similar.
Similar, because they are triangles, they belong to the triangles family, but the size, shape, and every, like this, you can say the size of this triangle is bigger and the size of this triangle is smaller. So they belong to the same family, but they are of different dimensions. Clear, Faris?
Yes.
Yeah. So basically, in similarity, the figure looks like same, but the dimensions and the you can say the dimensions can be different. So that's what similarity is. Clear, Faris?
Yes.
Very good. So Faris, one more thing. Let me ask you one more question right here. So sorry. Yeah. So Faris, if oh sorry, Faris, Adil, if I say that, suppose this is a square and this is a rhombus. So Adil, tell me, are they similar or not?
They're similar.
They are similar. How? Can you tell me?
Because that's a square.
That's a square. Another one, like, do you think that this is square?
Yes.
You think that's a square?
And no.
No, Adil, that's a rhombus. So it's a square and it's a rhombus. Clear, Adil? So these are different figures. Square has 90-degree angle. Like you can say rhombus has 90-degree angle. No, no. The angles are different. Yes or no?
Yes.
Yeah. So it means that for the criteria, we have basically, for similarity, we have different criteria to, you can say, to identify whether the triangles are similar or not. Clear?
Yes.
Okay. So let's take one example, one exercise question directly. It's a straightforward question. Like in the introduction, there is not so much thing in the similarity. Yes, Adil. So let's do this together. We have to identify whether the given figures are similar or congruent. So Adil, tell me, all circles are congruent or similar?
Similar.
Similar. Why? Because they form a common shape, which is circle, but they can have different radius.
Yes.
Yes, now different radius can be there. Adil, if the radius, everything is equal, what kind of circle is that? Like, are they congruent or similar?
Congruent.
Congruent. Congruency means everything is, just a second, everything is equal. Yes or no?
Yes.
So it is right here. I'm writing similar. Clear, Adil? Okay. All
Yes.
squares are similar or congruent?
Similar.
Similar, because it may have different dimensions. Square like 90-degree will be there, but they may have different dimensions. One square can be of 3 centimeter, one square can be of 9 centimeter. All now, Adil, tell me, isosceles or equilateral, which triangles are similar?
Nice.
Yes, Adil,
Equilateral.
equilateral, not here. Suppose in now see that thing. These suppose that these are equilateral triangles. So angles will be in a 60.
Yes.
Angles will remain 60, whether it's the dimension can be anything. The angle will remain 64. Angle will remain 64
Yes.
equilateral triangle. Clear?
Yes.
Yeah. So equilateral triangle writing. Two polygons of same sides are similar. These are the two conditions, Adil. If their corresponding sides, okay, let me understand, tell you, explain that to you. If this side, any two corresponding sides, so if this is I'm taking a side AB, Adil, AB and C and PQ and R. So Adil, what is the corresponding side of AB in triangle PQR? So Adil, whenever we say corresponding, it means that just see this thing. AB here and PQ is in this side. So AB is also in left side, PQ is also in left side. So AB basically is corresponding to PQ side. Clear?
No.
BC is the base in triangle ABC and QR is the base of PQR. So BC is representing PQ corresponding to PQR. Clear, Adil?
Yes.
Now, similar thing, AC is on the right hand side. Yes or no?
Yes.
One more thing. Let's name the triangles ABC and PQR. So if I take AB side, so which side is basically corresponding? PQ, na? Starting
Yes.
towards PQ. If I'm saying BC, so what is the corresponding side? QR, na? QR.
Yes.
If I'm saying AC side, which side is corresponding? PR, as suggesting the name. So if any of the two sides are proportional, if any of the two sides are, you can say that this AB by PQ is equals to BC by QR. These are the two sides, na? Proportional. If they are
Yes.
in proportional and one of the angle, suppose that this angle B is equals to this angle Q, and one of the angle is equals to this, corresponding to this, because angle B, angle Q. Naming suggests that angle B is representing angle Q. Clear, Adil?
Yes.
Yeah. So it's saying that if the corresponding angle, one corresponding angle and two corresponding sides are in ratio, then the triangles are similar, are equal. If their corresponding angles are equal and their corresponding sides are in proportional. Clear, Adil?
Yes.
Yeah. So that's how basically this is the similarity of the triangle. Clear, Adil?
Yes.
Now let's understand the similarity of triangles in the coming. So this is the introduction. Is that clear, Adil?
Yes.
Okay. Just a second. Okay, so Adil, we have the, you can say, if we need to basically, if we say the similarity, so we have the first thing, the conditions. If the triangles, for the similarity of triangle is that if the two triangles, we have to say that two triangles are similar, we have to say that their corresponding angles are equal and their corresponding sides in same ratio or in proportion. Adil, okay?
Okay.
Okay, let's understand the thing first, how to basically. So first is, corresponding angles are equal. Second is, okay. So basically for this, we have first theorem, which is called basic proportionality theorem. Okay. The first theorem is the basic proportionality theorem. Okay, so let's do this thing. First theorem is the theorem 6.1. It says that if a line, we have to prove this theorem. It's a very important theorem, Adil. Okay, so like, is it like this theorem has been proved in your school or not?
Yes.
Yes, okay. So Adil, is that clear, everything till now what we have covered so far? Any doubt?
Yes. No.
Okay. If a line drawn, if a line is drawn parallel to one side of a triangle, to intersect the other two sides in distinct points. The other two sides are divided in the same ratio. Okay, so let me explain that to you. Basically, what it basically saying that, suppose that let's draw one triangle here. It's one triangle here. It's basically like this. Okay. The question, this theorem is saying that if a line is drawn parallel to one side, suppose that this is the line, I'm drawing one line parallel to this line. Okay, for Adil?
Yes.
Okay. So it's intersecting the other two sides, yes or no? Obviously,
Yes.
these two sides are getting intersected. Intersecting means meeting. Suppose that this is A, B, and this is C. So I can write this as D and E. Yes or no, Adil?
Yes.
So it's saying that the other two sides, it means that if the line is parallel to this sides, so this ray, it means that to prove AD by DB is equals to AE by EC. It's saying that if this line DE is parallel to BC, so it should divide these sides into proper ratios. Clear, Adil?
Yes.
Okay. So Adil, to calculate, to basically prove this theorem, what we need to do is that proof. I will construct one perpendicular on this side, which is EN. Okay. And one construction will be right here, which is M. So this is a perpendicular. So it will be 90 degree, yes or no, Adil?
Yes.
Okay. So Adil, if I have right, and one more thing I will do is that I will connect this DC points and BE points. Okay. Now let's come to the part construct. What I've done is that I've constructed EN perpendicular to AD. Yes or no, Adil?
Yes.
Yeah. EN perpendicular to AB and DM perpendicular to AC and join DC and BE. Yes or no, Adil?
Yes.
Okay, that's great. So Adil, let's come to the point. If I need to calculate now, first of all, we have to calculate the area of the triangles. So basically, I'm taking the triangles, Adil, A, D, and E. A, D, and E. A, D, E. Clear, Adil? So
Yes.
area of triangle AD E is equals to, so what is the formula of triangle? It is half base into height.
Yes.
Okay, half will be remain as it is. Adil, if I'm taking triangle ADE, what will be the area of the, what will be the height or what will be the base? Can you tell me? Adil, this will be the base ADE. ADE. So this will be the base now. And
Yes.
perpendicular is what? Perpendicular is the height of the triangle. If I'm dropping here, so it is the height of the triangle now. So I can write base is AD into EN is the height. So this is our equation number 1. Okay. Now area of now if I'm calculating the area of triangle BDE. Okay. Now Adil, see that thing, triangle BDE, this triangle. So Adil, you can see that this is an obtuse triangle.
Yes.
So if the triangle is obtuse, we drop a perpendicular from the height. So it will go, because it's an obtuse, so it will be a little bit tilted like this. So if I need the height, I will drop one perpendicular. So this will give me the height, this perpendicular.
Yes.
Okay. So if the triangle is BDE, can you tell me which is the perpendicular of BDE?
DE.
DE. I'm asking the perpendicular. Perpendicular is not DE, dear. Perpendicular is EN, because this is an obtuse triangle. So perpendicular will be outside the triangle. Okay.
Okay.
Yeah. So it's half base into height, it is half. Base is triangle BDE. So BD is the base and EN will be the. So this is the equation number 2. Okay, Adil?
Okay.
Okay. Again, I'm taking the triangle. Now, right now, I'm taking triangle DEC. 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 So Adil, tell me if DEC is also an obtuse. So this DM will be the perpendicular because obtuse triangle have the perpendicular basically outside.
Yes.
Yes or no? So area of triangle DEC is equals to half base into height. Now Adil, tell me what will be the base of DEC triangle?
EC.
EC, very good. What will be the perpendicular of the DEC?
DM.
DM, very good. So that will be your third equation. Clear, Adil?
Yes.
Okay, one more thing, Adil. Triangle DEE or ADE also have the perpendicular DM.
Yes.
The upper triangle have two perpendicular. Now one is EN, one is DM. We have calculated the EN wala, but we have not calculated DM one. So we can also calculate the area of triangle ADE again as half base into height as half into its AE into DM. Yes or no, Adil?
Yes.
Yes or no?
Yes.
Yes, very good. But in this case, AE will be the base for this triangle because AED perpendicular is on AE. Clear?
Yes.
So this is your equation number 4. Clear, Adil? Now see that thing, Adil. We need AD upon DB. AD upon DB or BD, you can say. So if I divide equation 1 by 2 and if I divide equation, just a second. So one more thing is that ADE and BD. Okay, I'm dividing equation 1 and 2 first. Dividing equation 1 by 2. I'm dividing equation 1 by 2 because I can see that 1 by 2 will cancel out, EN will cancel out. So AD by BD will be left. So area of triangle ADE is equals to half into AD into EN upon area BDE is equals to half into BD into EN. Yes or no, Adil? So this will
Yes.
cancel out this. EN will cancel out this. So what will be left is that AD upon
B.
DB. BD or DB, same name. It's like either you write DB or BD. It would be same. It's not different. Okay. AD by DB. Clear? This is your equation number 5. Clear, Adil?
Yes.
Okay. Now I am dividing equation 3 and equation 4. So area of DEC upon now DC equation 4 by 3 because I need AE in the numerator. Is equals to half AE into DM here and upon में area half sorry, area DEC is equals to half DE. So it's not DC, it's EC into DM. So this DM will cancel out this DM and half will cancel out half. So what will be left is that AE upon
EC.
EC. This is your equation number 6. Okay. So now what I have is that I have area ADE divided by area BDE is equals to AD by DB or BD, you can say. And one next thing is the area ADE upon area triangle DEC as equals to AE upon AC. Yes or no, Adil?
Yes.
Now, Adil, somehow I have now see that if I somehow equate make this left hand side equal, so if the left hand side of both the equation are equal, so I can equate the right hand side as well. So if I able to equate the right hand side, so that's the theorem will be proved, because I want to prove that what AD by DB or BD is equals to AE by AC. Let me share my screen again. Yes, just a second. Let me share my screen again. Yes or no, Adil?
Yes.
So Adil, now see that thing here. This triangle BDE triangle and DEC triangle have this common base, which is DE. Look at the screen, Adil, if you are able to collect me. Triangle BDE. DE is common, triangle DEC. Yes or no, Adil?
Yes.
DE is the common base. And
Yes.
one more thing is that DE and BC are parallel. It's already given. If a line drawn is parallel, it's saying it's already parallel. So Adil, basically, if this is kind of case, so there is one property of triangles. DE is parallel to BC and DE is the common base for both the triangles. BDE and DEC. Yes or no, Adil?
Yes.
So if that basically there is one theorem, if the triangle, if the basically lines are parallel and triangles are on the same base, so area will be equal. So that's how the area will be equal of BDE is equals to area will be equal of DCE or DEC. Why? Adil, can you tell me why? Because the triangles formed between parallel lines are on the same base, so their area will be equal. Clear?
Yes.
So Adil, now we have got this equation number 7. Clear? Now Adil, tell me, I can write in like if I have triangle BDE, so can I write DEC here instead of BD because both are equal?
Yes.
Okay. So substituting equation 7 in, what is the equation name? DEC BD 5. Equation 5. Just a second. Okay. So if I'm substituting this, so this equation will become area of triangle ADE upon area of triangle DEC is equals to AD by DB.
Yes.
So this will be your equation number 8. So Adil, equation number 8 of the left hand side of equation number 8 and the left hand side of equation number 6 are same. ADE by DEC, ADE by DEC. Yes or no?
Yes.
So can I equate both the equation because left hand sides are equal?
Yes.
Equating. Just a second. Equating equation number 6 and number 8. So this will be, from this you can say that AD by DB is equals to AE by EC. Hence proof. That's what we need to prove now, Adil.
Yes.
Okay, that's great. So that's how the equation, this theorem is proved. Okay. So copy this.
Yes.
It's a very important theorem, Adil. I'm continuously saying it's a very important theorem. Then Adil.
Yes.
So that's the theorem of the BPT. Short form is BPT. Okay.
Okay.
Okay, that's great. So let's do one question based on BPT. Okay, so Adil, let's solve this question here. So basically, there is one thing is given right here. So it's given what? The lines are parallel. AD, sorry, this is, if the line is this, DE are the points which basically intersect and parallel to BC. So DE line is parallel to BC. Okay. So you will
Okay.
write the first thing which is given. DE is parallel to BC. Okay.
Okay.
Yeah. So if it's already given, so I can apply the base BPT theorem because BPT theorem has the basic criteria, which is the line should be parallel. Yes or no, Adil?
Yes.
Yes, na? So if the lines are parallel, so AD by DB and AE by EC will be equal.
Yes.
First of all, let me write what we need to prove. We need to prove is that AD by AB is equals to AE by AC. Clear? So proof. So proof is the thing. So if the lines are parallel, so I can write AD by DB is equals to AE by AC. Not AC, it's EC. Yes or no, Adil?
Yes.
Very good. So now what I need to calculate, I need to basically make this DB as AB. So what I will do is that I will reciprocate. If I basically Adil, what I do is that I will reciprocate. Basically, I'm saying that I am taking the DB in the numerator and AD in the numerator. So if I'm doing on this side, I have to do this on this side as well, because math says that if you are doing on the left hand side, you have to do on the right hand side as well.
Yes.
Yes. So I can write this DB upon AD is equals to EC upon AE. Now, Adil, this is your equation number 1. If I add +1 on both the sides, is it allowed? Is it allowed to basically add 1 on the both sides? Because math says that if you are adding on the right hand side, you can add on the left hand side as well.
Yes.
Okay. Adding 1 on both sides. Equation 1. So basically, DB by AD plus 1 is equals to EC by AE plus 1. Okay.
Okay.
So Adil, if I take LCM of this, DB plus AD will be formed. Why Adil, is that clear? Why I've written AD in the numerator upon whole denominator of AD?
No.
No. If I take LCM, Adil, so LCM of this will be DB by AD and 1. This will be AD because 1 is there, na?
Yes.
AD and what is the LCM of AD and 1? It will be AD. So AD divided by AD is 1.
Yes.
And 1 multiplied by DB will be DB
DB.
plus AD divided by 1. What will be the answer? AD divided by 1.
AD.
AD. And AD into 1?
AD.
AD. So that's how this forms. Same case here, EC plus AE will be equal upon AE. Clear?
Yes.
Very good. So Adil, tell me, DB plus AD is what? AB, na?
Yes.
Yes, na? So it becomes AB upon AD is equals to AC upon AE. Clear, Adil?
Yes.
Now we have achieved the thing that we have basically what we have AD upon, we have achieved AB by AD and AC by AC. But what we need is that AD by AB. We have to reciprocate it. After that, we will be done with the proof.
Yes.
Clear?
Yes.
So basically what I will do is that I will take this, I can say that AD upon AB, because if I'm reciprocating on the left hand side, I have to reciprocate on the right hand side as well. So it would be AB is equals to AE upon AC. Clear? So that's what we need to prove. It's proved. Clear, Adil?
Yes.
Any doubt?
No.
Sure?
Yes.
Okay. So that's what the question is. Okay.
Yes.
Okay. So let's do one more question, Adil, because already just give me a moment, Adil, just a second. Just a second, Adil. Okay, so let's do one more question, Adil. Okay, based on the BPT theorem. Adil, is that clear, dear? Anything which is not clear to you in the previous question or in the theorem?
No.
Sure?
Yes.
Okay. Because this chapter is a little bit tricky in the starting, but when you proceed in the chapter further, so it becomes a little bit more easy. So Adil, one more thing is that you have an assessment after this class. Okay, do that in the
No.
just attempt the assessment in the app. Okay, dear.
Okay.
Very good. So basically, so this chapter, basically this question is there. We have to prove that PQR is an isosceles triangle. So Adil, tell me what is the property of an isosceles triangle? Can you tell me any basic property of isosceles triangle? Yes, Adil?
Two sides are congruent to each other.
Two sides are
Congruent.
congruent. You're saying congruent.
Yes.
No, not two sides are congruent. Basically, if the two opposite sides are equal, either PQ and PR are equal. So if this is are equal, then the opposite angles will be equal, which means that Q and R. Either if you prove that Q and R are equals, so this opposites angle should be equal. If the two opposites angle are equal, automatically the other two sides, the opposite sides will be also equal. If you have proved that the opposite two sides are equal, so automatically you can say that the triangle is isosceles. Clear, Adil?
Yes.
Okay, so let's now, Adil, the question is already given that PS by SQ and PT by TR. So what can you conclude that if the triangles are, the sides are in ratio of this triangle? I've told you in the previous example itself that if the triangles basically if this is the case, so what is basically this line to this line? Yes, Adil?
Congruent.
Adil, we are learning congruency or similarity,
Perpendicular.
not perpendicular. Dear Adil, the BPT theorem says that if the lines are parallel, then the sides will be in ratio. You can see that PS by SQ and PT by TR, the sides are in ratio. So I can say that ST and QR are parallel to each other because the sides are in ratio.
Yes.
Okay.
Okay.
Adil, focus a little bit, Adil, because I've seen that you don't focus up to the mark in the class, and that's not a good thing, dear. You won't be able to perform. Adil, have you given the maths test? Subjective maths
Not yet.
test? Last to last Friday?
Assessment.
Not assessment, subjective test of maths.
No.
Okay. PT by. So it's already given. So I can conclude that ST is parallel to QR. Yes or no?
Yes.
I can conclude now because the sides are in ratio.
Yes.
Very good. Now, Adil, one more thing which we need to prove that triangle PQR is an isosceles triangle. Clear? Let's come to the proof part. Adil, see in the figure, if the lines are parallel, so this angle S will be equals to this angle Q. Can you tell me why?
They're parallel.
They are parallel, but why this angle PST is equals to y angle PQR? Adil, when the lines are parallel and the angles are made on the same sides of the parallel lines, suppose that this is a parallel line, this is a transversal, so the angles are on the same side now.
Yes.
So these angles are called as corresponding angles. Adil, in the next class, go and learn the lines angle concepts of 9th class. Okay. Before coming to the class, go through and revise the lines and angles properties, parallel lines properties. Clear?
Yes.
What is alternate angle? What is basically the, you can say, what I'm saying, what are alternate angles, what are corresponding angles, what are vertically opposite angles. Clear?
Yes.
Very good. Now, Adil, one more thing is that, so what is given here? Something is given. Yes, PST, one more thing is given as that PST is equals to PRQ. It means that this angle is also given to this angle. Suppose that this is equation number 1 and this is your equation number 2. So I will see that thing PST and PST, right hand side, left hand sides are equal of both the equations.
Yes.
Yes or no?
Yes.
So I can equate both the left and right hand side, right hand sides of the equation because left hand sides are equal.
Yes.
So I can write from equation 1 and equation 2 PQR is equals to PRT. Okay. So RL, I've told you that if the opposite angles are equal of a triangle, so it means that it means that the triangle is isosceles.
Yes.
Yes or no?
Yes.
Yes. So that's why PQR triangle is an isosceles triangle. Clear, Adil? That's what we need to prove. Hence proved. That's okay. So that's how you will prove. Clear, Adil?
Yes.
Okay. That's great. Okay. So Adil, so we have done the BPT theorem. Okay. So in the next class, today only we will be having an assessment, no homework. I won't be giving any homework. I have to cover some numericals, and then in the next class I will be giving the homework to you. But right now, assessment is active. You have to give the assessment. Okay.
Okay.
Okay. So, okay, dear, that's all for this class. Okay. So go and take the assessment and revise the concepts, lines